A number of years ago, a friend brought me this lamp that had been left abandoned by a coworker at their company. Said it didn't really work that well. I've used it for a long time and it doesn't work that well. And it should just be a simple AC connection all the way through to the halogen. There's also a stripped screw here, and so I've had to use just a paper clip to hold this in basically a fixed position. And I don't really care about that. That's just not that big of a deal. But I do want to figure out why when you plug it in and turn it on, it doesn't necessarily power on. Sometimes it'll take just an hour or two, and eventually it'll turn on. Sometimes tapping it will help it turn on. In either case, it's replaced bulb, so the bulb shouldn't be a problem. But we'll want to figure out why that is, because it should be a simple circuit, and if it's not powering on, generally there's a broken contact in there, and that could become dangerous. I'm going to do my best to disassemble it here on camera. So first we're going to just release this piece of glass and get this light bulb out of here so it doesn't get broken. These three should just twist away, and there's the piece of protective glass. So these light bulbs, you should do your best not to touch directly. So as I understand, the theory is that the oils on your fingers get onto that glass surface. They can create hot spots during heating, and the glass can crack from the external heat on those hot spots. But there is the G8 50-watt bulb. And I'm just going to check and make sure this bulb really does work. I believe it does. Set that to continuity and put the tester across the pins, and yep, that light bulb makes good contact. So it should turn on if power's getting to that socket. Okay, I see 3 more screws here, this peg, and I'm going to release this paper clip so that I can move this freely. On the top of the back, there are more screws here and underneath as well. I think what I'll do is remove this little twist nut so that I can take this completely away. And the screw should come all the way through now. Loose bracket here on top. And this will be separated. I think there's also a little peg on the inside. We'll just make sure this doesn't get lost. Okay, I should be able to get to the 2 screws now that are on the top of this, on the back and on the inside. Okay, and this is separating now. You can see the back of the socket there. Looks like it's held on by 2 nuts. In there. I'd like to get better access to this. It looks like this is 2 pieces of metal. Those 3 screws, it's like to hold them together, and then this guy as well. And that's this one. But we're still connected to that wire, and that's going to be difficult to remove. There are 2 screws here on either end of the socket, and those have their connections lead to the nuts on the back of this guy. Let's see if we have any slack in the cable here. If I just pull it forward, I do have some. It's enough though to potentially get me on those pliers onto those nuts there. I'm just holding the screwdriver on the inside of the socket so that this nut and the screw come apart. It's going to be fun to put back together, that's for sure. The rustiness in here, it does seem to indicate that there's probably corrosion on the wire. That would explain why it doesn't turn on right away. Once there's enough heat on that point of resistance, it'll actually arc to sort of melt the contact back together. Okay, we'll try to get into this back one as well. Okay, is the socket going to come out now? Take the screws out. Use my finger from the back to press this through as I unscrew it. Okay, can we separate this? Great. Okay. That'll make working on this a little bit easier. There are still these two pieces which are captive, but you can see the wiring there, and that is extremely stiff at this point, and the insulation is definitely hard and cracking on these two wires. So it doesn't surprise me that the contact is intermittent. I'm just going to twist these back and forth and see if I can disconnect the socket here. I feel little pieces falling off as I'm doing this. Okay, that socket actually looks fine. A little rusty on the two screw holes, but with some contact cleaner in there, this might work just fine. As for these wires, I definitely want to pull back to the past the part where the really stiff contacts are, where the stiff insulation is. The insulation is harder than the cable inside. Not good. And that could eventually have just caused a complete short. I do want to slide this off of the wiring, which does mean coercing those cables into a straight enough hole that they can allow this to slide off. Okay. Yeah, that is the state of the wires we're looking at here. That's not pretty. A few inches back there, so everything's fine. So I think that the heat inside this housing caused this to completely harden and decay. So that's something to consider, is whatever we replace this end with and put back in contact with the fixture is going to have to endure really hot temperatures. That said, let's see if we can just slide this shielding back far enough that we get to the healthy wire. You can see it's actually the same silver wire that's going into the lamp in the back here. I don't know if that's treated or if it just transferred the heat through the wiring and burned the coloring off of the exterior of this. That's kind of crazy. I do have replacement silver lamp cord, but if this is what's going to happen to it, that's something to consider. It might be one of those where it's fine until it isn't, and then we do this type of thing again. I want to see how difficult it would be to rethread this cord in. Presumably there is a junction box on the inside of the housing here. Just adhered on that little felt pad. Looks like this is all just a weight here. Okay, so there is a junction in here between the switch and the lamp cord going up the tube here and the input line here. So I'm going to undo both nuts. These looks like crimp fit nuts, so we'll have to replace them, but pull these off so I can extract this lamp cord all the way out, and we'll get some replacement lamp cord in there. Might have to cut these, but I'll just try some pressure. Like so. Now is there keying on the lamp cord? There is writing on the switched leg. I'll have to see. I'm not sure if it even matters by the time it gets to the fixture, because it's not a polarized fixture. Okay, let's extract this lamp cord. Pull this up this way here. Okay, that's free, and then we'll pull this down this line. I'm wondering how fun this is going to be to try to put back in here later. Looks like this will do better without this nut here. There is this piece of lamp cord. I'm going to pull this white sheathing back as well. Reuse that. All right, you can see that this is just one piece of wire, but that heat has really warped this other end. Well, let's see if my replacement cord is the same gauge. This is just off the shelf lamp cord, silver color. And one thing I wonder is if it's any amount larger, that's a pretty tight slot to put it in. We'll see if this can go in here. It feels similar, but a little bit bigger, so give it our best shot here. At least it is newer and more flexible, at least for now. Obviously, we'll not be using this plug end since the plug on the lamp is on a second line. The other thing is, considering feeding, definitely going to be hard to pull wire out of these little holes. So I think what I'll do is I'll cut enough to go down and up, and we'll feed both from this direction. I'm going to pull off about the same amount as on the other line. I'll give it just a little extra so that I can adjust it if necessary. And cut that. These ends are already tinned, just like would go into this socket. So I'm going to send these up the long way and then send this cut line down, and we'll crimp and splice that there. See if we can get this in there elegantly. It is tight. If it's too tight, then this metal will tend to shave off the outer edge of the insulation, which is okay as long as it never makes metal contact. Just a tiny little bit of the edge is not going to hurt anything. As difficult as it might be, I want to see how well it does thread backward. Just give me some indication of how much space there is in here. It actually fits just fine. Don't know what my chances are of being able to pull that out back there, but we can try it this way. Yeah, I can only get about that much in before there's just too much friction. Put a little bit of silicone lubricant down the inside of this and make that a little bit easier to slide here. I'm going to tilt this downward. Okay, and that's all the way through there. See if I have any better luck in starting on this end. Appears to be going, just it's a little process. Let me see if I do have any thinner wire. Well, I found a different piece of wire in my scrap collection, and it's a different color, which I'm not that annoyed about, and it's definitely thin enough that I think it'll make it through this tubing without putting up nearly so much of a fight. Pull this back out of here. You know, it might just be almost as hard as putting it in. It's definitely making progress, but I don't think that would have taken all day. Save that for something else. Untie this. Try this again. Yeah, not nearly so tight. Okay. Okay, and that's coming through. I'm just going to pull that couple inches of slack between the housing and that, and then we'll probably end up cutting some because I don't want extra cord up in that hot area, but we'll leave that there, which leaves us with plenty to go down into the base. Okay, now routing this, I want to make sure that it stays clean because I don't think twisting it in that pipe is going to be easy. pull the rest of this through. Make sure that this can articulate as much as it needs to. Good. And not silver anymore, but hopefully working. Rewire this. Cut that about there. Get wire strippers and nuts. Okay, we can just peel these two pieces apart a little bit. Great. Give those a little bit of a strip on the end. I'm gonna do a little soldering as well before I put the nut on, because these are connections that, if they got slightly weakened, could become pretty hot. All right, I can go back in there, and then let's reassemble the base here. That's about right. That's about right. Okay. So I can also reinstall this screw that goes across here. Let's grab this little white piece of shielding here. There we go. Get this back as far as we can here. Now the order here is going to matter. So I believe this one will go on first. This loose piece I'll want to keep in here. I'm not going to put this together yet, but I'm going to just put this screw here to hold it so that doesn't fall down. Okay, and then inside, the next thing we want to do is get this guy. Just make sure that that's in place so that we get these all in the right order. Now this one, we can actually wait until there's a socket to attach it to. But in order to attach that socket now, we need to get these two little wires prepared for the contact points in here. To do that, I'm going to separate these a bit and then strip off the ends and tin them with solder. I'm going to strip off less than I did for connecting the wire nuts. Just enough to make solid contact with the inside of that fixture. Add a little bit of solder to each of these. This just keeps it very stiff as we connect that solder contact to that fixture. It's looking fine, but a little bit bulbous on both counts, so we want to kind of bring that solder back. I think at this point we're ready to insert these into the back of the fixture. It's just one on each end of this. Just make pressure fit like so. This one seems to be solid, but this one isn't. So actually I'm going to thicken it up again with that solder tip. Just make it grab the end a bit more. Okay, both counts this feels pretty solidly secured. At this point I'm going to put that last piece of metal behind it, like this. We can insert those 2 screws. And then back on the back, we'll start putting those nuts back. In both cases, I'm just going to hold the nut with the pliers and use the flathead since it can get into these angles better. Just cinch them down. Great. This back in the same order it came out in. And at this point, I'm going to actually pull some of this wire backward. Oh, this is supposed to be on the outside of that. Okay. Well, it's just like that. Okay, let's try this again. That can now go here. These 3 can hold this together. These can go together as well. Now this might be difficult. I do want to coax some of this wire back down the pipe and out the other side. I may remove this again to make that straighter shot. As we pull this in, it's probably going to bring some of that shielding with it. I'm just going to make sure that shielding also makes its way into the lighting assembly. That's about right. Move this down out of the way. This guy in here. First thing we'll do is put this piece right through the center there. Hold that in place, and this piece just fits on the outside. That. From the back, let's through all 5 of these elements. There we go, right through the center. This end, despite that this is stripped, we'll use this to pinch that off. See if I can find something for that later. All right, I'm gonna put my little jerry rig paper clip back in to hold this up. All right, and we'll do a number of quick tests here. So what I don't want to see is any shorts without the light bulb installed. Continuity. No short. Switch. I think that's off now, actually. No short. Great. And then we'll install the light bulb. Again, trying not to actually touch the glass. And if that light bulb's good, we should now have a short when the switch is on. I think the switch is off right now. And the switch is on. Oh, that's not great. Let's just adjust the light bulb a little, make sure it's making good contact. There we go. Switch off, no contact, switch on. And there's our light bulb resistance. Okay, that seems to be in good shape. Install our glass cover again. Slot that between all 3 of these. Okay, and we'll give this a test. Perfect. Hopefully this is a reliable repair. The last thing I guess I'll do is I pulled some extra slack into this part of the loop here. I'm just going to see if I can shove it down into the base. Full range of motion. And there we go. Took a couple of tries and to work around a couple of complications, but that is a successful repair. So after the edit, I realized there were a couple of things I meant to show, but neglected to. One is the rating of the wires that were used beforehand and in the store-bought example that didn't end up working, and also in the spare wiring that I had eventually installed in this lamp here. So here's the original wire. This is two ends of the exact same cord. And like I said, I think that the heat had actually caused all of this to happen. I don't believe any of this was treated at the end to be any different than the rest of this regular, lamp appliance cord. The end that was installed in the base here wasn't even tinned. It was just twisted together and then crimped with that wire nut. But the end that was installed looks like the ending here was tinned with solder. But that heat really did just take this regular silver, or really transparent insulation and darken it, blacken it, harden it, and then cause it to become so brittle that really it can't flex with the wire, and even in the heating and cooling cycles probably was creating small gaps for corrosion to get in and cause problems in this wiring. It's so hard that if I try to bend this, and that's exposed copper in there. But one thing I did want to point out, looking at the original wiring specifications that were installed here, just want to see what the temperature rating is. (105°C), which is a pretty much standard AC wiring specification. So here's the brand new replacement that I did find that unfortunately didn't fit in the piping that went through that lamp. But it would have also been 105°C rated at 300 volts. So if that had worked, it would have been an equivalent. Here's a fragment of the wiring that I did end up using from my spare collection. And it also does seem like it has essentially the same specification and rating. Despite having a slightly smaller outer shield, it probably will perform about as well as the original did. And as well as the original did is good and all, but obviously the original didn't perform particularly well. It basically failed eventually. I don't know what hours this has on it. Like I said, it was given to be used and basically abandoned. So it could have been turned on for hundreds of hours or maybe just a few. We'll really have to see. One thing I do see is this top has some venting on it, which is obviously probably intended to dissipate heat out of the top as it heats up. There's not really any air inlets on the bottom side to let air through this enclosure. So one pretty cheap and dirty mod would just be to drill some holes in this piece of sheet metal so that there is some inlet for the air that naturally escapes via convection here. That might keep the interior of this enclosure cooler, and it might prevent this new replacement wire from getting nearly as hot. I might do that because I don't have any evidence to suggest that this new repair won't last longer than the original, and other than the composition of the rubber and the insulation on this replacement cable, there's really no difference now than before. The other thing that I neglected to do, I mentioned it in the video and it never did it, was to put contact cleaner on the inside of that porcelain fixture that holds that light bulb secure in its socket. And I can actually see already that there's some evidence of this. If I turn the fixture on and then tilt it, at certain points, I was finding that it actually did cut in and out. This might not happen at this point, but it's always during the demo that these things don't work. Just 10 minutes ago, when I would tip it to the highest point here, it would actually cut out until I brought it back down, and that has to be because of those metal contacts adjusting their position in that fixture. So since I know how this works at this point, I think all I really have to do is release these two screws in the back of this, and we'll gain access to the back of that. We'll just put some contact cleaner right in there and twist it back and forth just a little, and we'll hopefully get a more reliable long-term connection inside that porcelain. Okay, well, given that I couldn't reproduce the problem, it's at least as good as before. I haven't introduced any additional problems, it seems. But with contact cleaner in those previously very overheated and corroded slots in that porcelain, it should have better contact now, especially after exercising it a bit as I did when I twisted it back and forth. So that should help this thing last in the long run. So the last thing I can do is give it about a half hour under a thermal camera and see how much heat is dissipated here and how hot this enclosure gets without any modification to the enclosure. I'm inclined to think just a few holes drilled on the bottom side of this will cause it to dissipate more heat and be cooler. But let's test it and see if we can get some numbers on that before modification, and we'll probably go through with modification and see what those same numbers are afterwards. So this is an imperfect thermal overlay. It will probably work for the most part, but when we have hot spots of the reflective surfaces, that will especially contrast with the heat of other objects here. I'm going to turn off the overhead lights, which are going to be reflected in those surfaces. Wait for those to cool down a little bit. You see if I cover each one of those, that'll be reflected. So we'll just wait for that to cool down a little bit here. Okay, while this is still cooling, the hottest reflective temperatures are about 80 degrees Fahrenheit, 27 Celsius. I'm going to go ahead and turn this light on now and see over the next half hour how hot this lamp gets. Immediately we're just over 27, but we'll see once the accumulated heat starts to dissipate out of the top of that housing what the highest hot spot is. We're climbing up to 28 already. We're up to about 43 Celsius and climbing pretty steadily at this point. At this point, we're 10 minutes in and we're at 57 Celsius and still climbing. We can currently see that heat dissipating off the exterior shell of that enclosure, and that paperclip that holds it up is standing out by contrast. So we'll keep letting it climb here until it stabilizes. "15 minutes in, we're about 64.5 degrees. Still climbing, but much slower than before. We're probably reaching equilibrium soon. Still, that's 64 degrees radiating out of the exterior of that assembly. So the temperatures inside there and the temperatures that that wire is experiencing are probably a lot higher than 64. Actually 65 right now as I read it. So that 105 degree rating might end up being nearly what that's experiencing. We'll see what eventually this exterior housing reaches. At 20 minutes in, we're at 67.5 degrees, still tending to climb, but only just. We're starting to find that equilibrium point here. 67 on the exterior is pretty hot, but that is meaning it's dissipating that heat out of the exterior and essentially keeping the interior cool enough to survive those extreme temperatures. We'll let it continue going up to 30 minutes here.
At 25 minutes, we're about 68.5 degrees Celsius here. That has still climbed over time, but we're looking at about 1 degree or so every 5 minutes or so at this point. So it's very close to equilibrium. We'll see at the 30-minute mark if it's higher or within margin of this. So even before reaching 30 minutes, we're at 28 minutes right now, I am seeing it bounce between 68.9 and 68.7 and up and down and up and down. So I feel like that is around its equilibrium in obviously this uncontrolled room. So ambient temperature will slightly affect this, but at this angle, which is pointed slightly downward, as though it's pointing back on itself, the whole lamp is tipped upward so that that thermal camera can focus on it. 68.7 to 9 is around what it reaches. And that isn't perfect for its flow of air. That ventilation is only really on its front. And holding my hand above it, I feel a little bit, but I don't feel much. That comparison, really, you don't see any thermal signatures off my hand because that is so hot at that hot spot right there. We are at 30 minutes at this point. 68.7, 8, 7, 9, 7, 8, 7, 7, 8. So that's its equilibrium. I think I will drill a couple of holes in the bottom here, just near that wire where it enters, and that'll cause that flow of air to reach its way to that top, increase the flow out of it, lower the ultimate temperature of its equilibrium, and also provide a draft right over that wiring area on that point here. I'll turn this off now and wait for it to cool quite a bit. And yeah, still seeing 68.8, 68.9. So that is the ambient temperature of this housing. We'll wait for it to cool down now. Okay, the hottest point is now 33 degrees, which should mean my hand is starting to register by comparison in the heat scale. So I think at this point I will go ahead and try to drill a couple of holes in the bottom of this. That will be easier if I take this apart yet again, just to a preliminary level that I can get to the insides of this, so that metal shavings won't accumulate in there. And that's all I really need here. Get this one as well, so I can lay this flat. I think I'll just do one on each side of this. Just knock these sharp edges down a bit for safety, just when handling this thing. Okay, those are no longer sharp to the touch. They're not perfect, but that's just fine. We'll reinstall this. Help angle and move the light around. Test that it still works. It does. Okay, and we'll set this in basically the same position as it was the first time. We'll see where equilibrium is now that there's a couple of vents to encourage that flow of air through that housing here. It may lower the temperature a bit. I'm hoping that's the case. Even if it doesn't, that's at least good measure and a good experiment. We'll turn this on now and see what the hot point is in about 30 minutes. So at 5 minutes, our hot spot is 44 degrees and climbing. At 10 minutes, we're at 59 degrees and counting. 15-minute reading here, looking like 64.5 degrees. 20 minutes in, 66.5 degrees is about the average we're seeing there. It's still climbing. 25 minutes in, we're looking at a hotspot of 67.5 degrees. All right, we're at the 30-minute mark there, and we're still looking at 67.5 degrees Celsius. So really that's at equilibrium, and it has been for the last 5 minutes at least. So definitively, those 2 holes we drilled did make a difference. That's about degrees Celsius cooler at equilibrium than we had before. And this isn't optimal. This is still tilted downward. But in the long run, if that cord was as good as this cord is, that degrees Celsius should make this cord last somewhat longer. So I don't regret drilling those 2 holes. We'll see some amount of benefit from having done so. So I think that will do it. This lamp is certainly going to work, at least for the short term, hopefully for the long term, a little bit cooler and with a fresh lamp cord.